All right, this is lesson 20, solutions to inequalities. Today we're going to talk about these things called compound inequalities. So let's read the blue objective on the bottom. Ready and begin. I will be able to create compound inequalities to solve problems involving them. Okay, good. So be able to create compound inequalities. Okay, good. So that is the goal for today. So here's the idea of a compound inequality. So in real life, let's say that I was like, or let's say I wanted to get you dessert, okay? I wanted to buy you dessert. And let's say you're like, I like pie. Or I like ice cream. Am I going to get you a plate of pie and ice cream at the same time? Would that be okay? Yeah. But I said I like pie or I like ice cream. So would I want to give you both at the same time? No, like waiters, I know that this has happened. I've been out with friends. They're like, oh, I like pie. And then they're like, oh, I want ice cream. So then they give it both at the same time. And they're like, no, I don't want it together. Some people like that, right? Does that make sense? So that means you can have one or the other. So here's another example. I like pie and ice cream. I like pie and ice cream. Would a waiter or waitress want to give me both? Yeah. Would I be happy? Yeah. Does that make sense? Whereas the first time it said, I like pie or I like ice cream. Not both. Would the waiter be okay with giving me both? No. Okay, so that's kind of what we're doing with numbers today. So I'm going to skip through this activity on this. This is, if we have time at the end, just as practice, we'll go through this, okay? So sorry about that. Okay, compound statement. You don't need to write this down, but this is what I talked about with a compound statement. In math, it's kind of like the pie and ice cream idea. Eyes up here, please. It's formed when we combine two or more simple statements. So like I could say like, oh, I like pie and I like ice cream. Well, I could say the number or the answer could be greater than 2 or less than 10. Okay, or here's an example. My age is greater than 30 and less than 40. What's my age about? What can you guess my age is about?
31 to 39.
Good. Does that make sense? 31 to 39, right? Good. That was a compound statement. A compound statement involving and is when they're both are included. So like I like pie and I like ice cream, therefore you know to give me both at the same time. Or a compound statement could be both or. It could be I want pie or I want ice cream, but not both. Okay? So we'll talk about that. Okay, here we go. Number 1 and number 2. Okay, so here we go. Eyes up here, pencils down, because I want to make sure you got this, okay? Okay, so this is a compound inequality. You see how there's 2 inequalities up here? We have 2 less than signs. Eyes up here. Damn it. Thanks. Eyes up here. Okay, so this kind of gets a little confusing, so what you could do is look at it as 2 different equations. So I could say this is like saying negative 4 is less than x plus 3. Okay, because I just want to cover the less than 7, right? Doesn't that look like an equation? Or another way I could look at it is I could cover the less than 4, or the minus 4 and the less than, make this other equation. I'll make it a different color. I'll make it orange, okay? So we got x plus 3 is less than 7, okay? Right? So I'll solve these separately, okay? And you'll notice that they'll look very similar. So this first one, the purple equation, I'm just going to solve it like I would before, SAD/MEP. Are there any subtraction signs by the x? No. Addition signs? Yeah, there is a plus 3, so I want to subtract 3 on both sides. When I do that, I get negative 7 is less than x, okay? So x is by itself, so I'm technically done. But just to make it easier, I'm going to flip the sides. I'm going to put x first and put negative 7 after. But I want to make sure since I flip both sides, I'm going to actually flip my inequality like so. You see how when I flip the whole thing? You'll see that? So that's the answer to the first one. Now I'm going to do the second one. Now watch what happens. Are there any subtraction signs here? No. Any addition signs? Yeah, what's being added? What's the opposite of add 3? Good. I'm doing the exact same thing here, see? So you got x is less than 4. Does that make sense? Okay, so now I have 2 answers. So remember when I said my age is greater than 30, or it's less than 39, I could say that the money in my account is greater than negative $7, but less than $4. Okay, so I would go onto my number line now, and I'm going to write negative 7. And I don't want to fill it in, right, because it's not equal to. And it's saying it's greater than, so I know it's going to go to the right, so I'm just going to kind of leave that there. Just put a little note there, I guess. And then this one's going to go to the left at 4. I'm going to put a circle. And it's going to go less than, so it's going to go left, right? So since they're both going left and right, all the numbers in between are going to count. So I'm going to make a nice line in between them. Using purple here so you can see. So what I'm saying is that my account has any numbers or any money from negative $7 all the way up to $4, but does not include negative 7 or 4. Does that make sense? Okay, so that's number 1. So what did I just do? I solved each inequality separately, here and here. You see how I did it separately? The second thing I did was graph each inequality separately, so I graphed them separately and then I interpreted my graph, okay, which means it's like, let's say this was my money in my account, okay, then that is the amount of money in my account. I have negative 7 to $4, but not equal to that, okay. Number 2, one more time, watch me do it one more time. We got negative 5, eyes up here, pencils down. Negative 5 is less than 3x plus 4, which is less than equal to 7, okay? So I'm going to make this 2 separate equations. I'll make 2 separate equations. I'm going to cover the less than 7, okay? So I'm covering less than 7. So let's just say this is the original equation. Negative 5 is less than 3x. Plus 4. And then this second equation I have to rewrite also. I'm going to cover the first part now. And rewrite it. 3x plus 4 is less than or equal to 7, okay? So I just covered them. Now I'm going to solve these separately. Purple equation. I asked myself, are there any subtraction signs in this by the x in the first equation? No. Any addition signs? Yeah, what's being added to the x? 4. What's the opposite of add 4? Subtract 4. So I'm going to subtract 4 on both sides. Got negative 9 is less than 3x. Okay. Any division signs by the x? Any division signs? No. Any multiply signs by the x? Good. What's being multiplied, everyone? 3. Good. Okay. Eyes up here. Okay. So we're going to divide both sides by 3. So negative 9 divided by 3 is negative 3, which is less than x. Okay. And we want to make sure it's a little easier to look at, so I'm just going to flip the sides here. So I'm going to put x first, put negative 3 last, and since I'm flipping the sides, I have to flip my inequality, right? You see that? So that's my first answer. Now I'm going to work on the orange equation. So the second equation, okay? Since I already did the steps here, I'm going to do the same steps. You see how I subtracted 4 on the purple equation? Let's just do that here too. We're going to subtract 4 because it's the same steps, right? Minus 4, minus 4. So you got 3x is less than or equal to 3. And then what I did is I divided both sides by 3. Let's do that here also. Divide by 3. Divide by 3. So x is less than or equal to 1. Okay, it's already in the right order, so I'm going to box it. Okay, now I'm going to graph it. I got negative 3. I'm going to go find it, circle it. Do I fill it in, everyone? Yes or no? No, it says it's greater than, so I'm going to make an arrow that goes to the right. Okay, and then I'm going to go to positive 1, make an arrow that goes, and I'm going to fill it in because it's equal to, it's pointing to the left. So I'm going to make a nice, like, I'm going to fill a line between the two, connecting them. And what this is saying is that any of the numbers that fit in from negative 3, but not including negative 3, all the way to positive 1 are solutions to here. Does that make sense? So let's pick a number. What's a nice number that's in between both of these two numbers?
Negative 1.
Negative 1. Let's pick an easier one. What's even easier? 0. Good. Okay, let's put 0 in here. What's 3 times 0?
0.
Good. Okay, what's 0 plus 4?
4.
4. So if the middle is 4, is it true that is negative 5 less than 4?
Yes.
Good. Is 4 less than or equal to 7? So is that true?
Yes.
Good. Let's pick a nice easy number that's bigger than where it's filled in.
1. 2.
No, well, 1 is included, so. 2. Let's put 2 in, okay? What's 3 times 2? 6 plus 4? 10. Okay, watch what happens. What happens if I have 10 here? Okay. Is negative 5 less than 10? Good. Is 10 less than or equal to 7? No. So does that make it true? Yeah, we wouldn't want to use 2, see? So only the numbers that are in here would work to make this equation true. Make sense? Okay, good. I like that. You did so good. Good job. So what I'd like you to do before you write, it's Friday, let's have 4s start today. 4s are going to talk about number 1. And then 3s, if you have a 3 today or someone else, talk about number 2. And then you're going to write. So we're talking. I want to hear you talk. Ready, set, go. All right, so the next example, I'm going to skip through some of this because we'll come back to it, okay? Because I want you to see what happens. Okay. I know it says guided practice 2, but let's change this to let's just do this as the next example, okay? All right, so let's write this down. Negative 4 is less than 6, or 6 minus x, which is less than 8, okay? I want you to think for 10 seconds what your first step would be. You're thinking, not talking. Okay, turn your neighbors. Tell them what strategy you would do in this example. Ready, go.
I would split the equation into different problems.
Okay, what's this first strategy we need to do, our first step of our strategy?
Split the problem into different equations.
Okay, good. So we're putting it into 2 different equations. So I'm going to use different colors on mine, but you don't have to. Okay. Good. Now turning to your neighbors, ask them, are there any subtraction signs? We're doing this together because I want to make sure we do it right, okay? Let's focus on the purple equation first. Purple. Turn to your neighbors, tell them, are there any subtraction signs by the x? Is there anything being subtracted from the x, everyone? Yes or no? Okay, eyes up here. This is where kids get confused. Eyes up here. Shh. Don't write anything. iPads down. iPads down. Thank you. This is where I want to make sure we got this, because this is where our kids make mistakes, and it's such a silly mistake because they don't get a concept. What's the sign in front of the 6 right here? What's the imaginary sign that's in front of it? No, a plus sign. Please don't talk. I'm teaching right now, okay? I'll give you a chance to talk in a moment. Would you agree that I could rewrite this second part as not plus 6 minus x, but let's rewrite it as negative x plus 6? Is this the same thing?
Yes. Yeah.
Do you all agree?
Yes.
Okay, good. So let's ask ourselves again. iPads down. We're not writing right now. Eyes up here. Okay. Are there any subtraction signs by the x?
No.
No. Are there any addition signs by the x?
Yes.
Good. Okay, now you could write. So we're catching up with Mr. Rink right now. Thank you for following directions. Okay. So I want you to rewrite it so that it has a flipped term here. Or flipped expression. Okay, so what's negative 4 minus 10, everyone? Negative 10. Bring down the less than. Bring down the minus x. And then the 6's cancel out, right? I got a question for you. Are there any division signs by the x? Good. Are there any multiply signs by the x? Okay, turn your neighbors and discuss that, or your group members. Discuss, are there any multiply signs by the x? Yes or no? All right, kids. Are there any multiply signs by the x right now? Yes or no? Who says yes? Raise your hand if you say yes. Raise your hand if you say no. Okay, Eva, why do you say that yes, there is a multiplication sign? Okay, good. X is being times by a negative. Watch up here, eyes up here, iPads down. This is like saying not negative x, eyes up here. Guys in back, can you both stay for just 2 minutes after class? I want to talk to you for a moment. So this is like saying negative 1x, right? Do y'all see this? This is the coefficient. So isn't negative 1 being multiplied with x? Good. So what's the opposite of multiplying by negative 1, everyone? Okay, let's all do that along with me. Okay. Do not finish the problem yet. What happens when you divide or multiply by negative on both sides? Okay, not all the time. It doesn't make it positive. I heard something over here. What was that again? Oh, okay, you see this inequality? What do I need to do with it, everyone? Flip it. So instead of this, we're going to change it to greater than or equal to. What's negative 10 divided by negative 1? 10, right? And then the negative ones cancel out, just leaving x on this side, okay? What should I do now?
Flip it.
Flip what?
The x and the 10.
Good, x and the 10, and then what else do I have to flip again? The sign, right? The inequality. So it should be x is less than or equal to 10. Let me see your boards. I want to make sure you did this first part, because this is like doing one problem. I want to make sure you do it right before we work on the second part of this problem. Okay, I'm going to be walking around. Show me your boards to get this correct. This is incorrect. Look at his and why yours is different. Good. 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 Okay. Let's use you see how you're using such a big marker? It just doesn't work like that. Let's use like 2 or...
It's too see-through.
It's too what? See-through?
Yes.
Okay, so fix your... Good. Okay, so here we go. Let's do the second half now. We have 6 minus x is less than 8. Can we rewrite this so it's a little bit easier to understand? What's a way we could rewrite it, everyone? Okay, minus x, Good, minus x plus 6. Do you all agree? Really? Do you all agree? Yeah, I agree too. That's good. Okay, good. Turn to your neighbors. Tell them what steps you would do on this one. What would you add and subtract, divide, multiply? What would you do? And I want you to work out the problem and tell me what you get. I'll give you about 30 seconds. Because we're running out of time. We're going to subtract 6 on both sides first. So we got negative x is less than 2. This is like saying negative 1x, so we're going to divide both sides by a negative 1. So x is going to be greater. You see that? We have to take this and make it greater because we are using this negative to divide on both sides. So it's greater than negative 2. Okay. Next thing I want you to do is make a graph, okay, on the bottom. So make a graph that looks like mine that goes from negative 12 to positive 12 with 0 in the middle. On this one, you should have had x is less than 10, so we're going to go to 10. And do I fill in the circle there? On this first one, yes or no?
Yes.
Yes, because it's equal to, so we want to include it. Okay, and it says it's less than, so I know it's going to go to the left here, right? What about x is greater than negative 2? We're going to go to negative 2. Do I fill it in? No. Yes or no? No, and then it's going to go to the right. So what I'm going to do is make sure that my line that goes in between is connecting the 2 dots, okay? Make sense? Okay, cool. Last one. We're going to go through this very quickly, okay? Okay, here we go. Last one. We're going to run out of time, so when the bell rings, please let's finish, or don't leave until I dismiss you, okay? So let's write this down. We got r is less than or equal to negative 2, and r plus 1 is greater than 10. So the first equation, I'm going to do this quickly. I'm just going to ask you for what you think. Okay, so I'm rewriting this. R plus 1 is greater than 10. Okay, first equation. Are there any subtraction signs by the r? Addition signs? Division signs. What's being divided? What's the opposite of divide by 5? Good. Multiply by 5 on both sides. Excellent. So we have r is less than or equal to negative 10. Did I have to flip my inequality sign on this one? Yes or no?
No.
No. Why not?
Because you weren't No, because not.
Because we didn't multiply by a negative number. Good. Okay. Excellent. Next one. Orange equation. Are there any subtraction signs? Addition signs. What's being added?
1.
Good. What's the opposite of add 1?
Subtract.
Good. Subtract 1 on both sides. So r is greater than 9. Okay? Makes sense? Now watch what happens here. Okay? Look at what happens when I graph this. I'm going to go to negative 10. Do I fill in negative 10 for this first one?
Yeah.
Yes, I do. Which way is the arrow going? To the left or to the right? Don't pack, otherwise you're going to take your stuff out to the front here. Okay? Which way is it going, everyone? To the left, right? Isn't it less than or equal to negative 10? Eyes up here. Everyone should not be on their iPads. iPads down. R is less than or equal to negative 10. So which way is it going? Left. Okay, look at the second one. R is greater than 9. Do I fill it in?
No.
No, which way is it going?
Right.
Good. Do you see how, are these lines crossing?
No.
No.
No. So what is that telling me? That it's like I want either pie or I want ice cream, not both. Okay? Write this one in your notes, please, and then we can pack up. So that concludes the lesson for today.